Okay, so last time we kind of did a lot with sprite animation. We made it look like the player was walking only when you're pushing a button. We made it look like the bees and the bats are flying when they're pursuing you, the player. Um, and what we're going to do a lot in today's two episodes, 24 and 25, is deal with kind of how the map handles collisions. So we're actually going to change to a different map on this next game here, the next version of the game. And this introduces things that you have in all sorts of video games where you can wander around and explore an area. Is you have certain places where you shouldn't probably be able to walk. So obviously I can go in the water and I don't fall in. I can go right through this rock. I can walk through a building. Right now, the way we have the map kind of shown is all we could do before was figure out where the edge was. So I can't go further than the edge, but I can go everywhere else. It treats every part of this picture the same. There's no difference to the game, to the JavaScript code here, between this grassy area where I should be able to walk and this rock where I shouldn't be able to walk. All the same. So how games kind of get over this was kind of the point of episode 24. And if I go, okay, RC mentioned in his video that he used this thing called Tiled. And what this does is it is a software program that lets you break down your map images into different regions or tiles. So we can see that I've got all these different tiles. It's a place where you can walk to. It's a way of breaking these images down into smaller pieces. And what you can actually end up doing is add a layer to this where you will have ones and zeros essentially stored in for each one of these tiles. So a 1 or a 0 is kind of a way to represent in the computer science world a Boolean value, which just means it's a true or false value. And I forget the way that we wrote it in here, but the true values means, at least in the way that we made this game, so if I had a 1 in the tile, so let's go back to our game here quickly. So I have all these broken down into, I think, 32 pixel grid. You have to look the actual size. It's in here somewhere, but it's broken into like boxes, and this stump happens to be on one tile. So I shouldn't be able to walk through a stump. So this program would let me store for this tile, I would have a 1. And it creates a layer here where you can have like different attributes, like can you walk through it? And then this tile right next to it is going to be a 0. So that means it's not a wall, it's not an object that I shouldn't be able to walk through. And you end up with, oh, what do we got? 40, I think this is a 40 by 40 grid based on my code here. So I've got 40 boxes going in the left and right direction. I've got 40 boxes going up and down. So I end up with a ton of different values for each spot on this map. So right here I would have a bunch of 1s because I don't want to be able to walk through the walls. But where I'm walking right now, I should have 0s. The boxes that have the majority water, I should have all 1s because I don't want to be able to do this and walk through them. I want to kind of keep my map logical and working like it actually appears, like I shouldn't be able to walk through walls or stumps, buildings. So let's see how we implement that. And I actually took away this functionality to show you what it looked like before, since my last episode didn't really have comparison. There weren't many objects to run into. So if we take a look at the code here, what I end up having is I actually took out this code, I commented it out. That was the function for is the positional wall. So what we're going to do on this game now is for the map, we can run this function whenever we need to, like whenever a player moves or a bullet moves, a enemy moves, they can run this is positional wall. So it passes in your grid X and Y. It runs it through point. So we passed in a point. So whenever an enemy calls this function or a player calls this function, you're going to pass in that object so we can get our X and Y position. We can divide by the tile size, which that's how big the grids were. Okay, 32 pixels. Okay, so what this does is if you are at, let's just make the math easy, I guess. If you're at spot 300, you're almost at 320, which is a multiple of 10 of 32, but you're bigger than, what would that be, 290, I'm assuming, roughly, 288, I think. So you are bigger than 288, but smaller than 320. So you're going to be in this function right here, figures out what tile you're in for the X and the Y based on your X and Y pixel value location. So if you're at 320 exactly, you're going to be on tile 10. All the math.floor does is it makes it an even number. It rounds it down all the time. So if you're at 10.2, we don't really care for this code that you're at 10.2. All we care is that you're in the 10th grid on the map on the X direction, which means you'd be 10 from the left side. And then you'll do that same thing for the Y. If you're at 10 for the Y, you're going to be in the first row because it's going to take 10 divided by 32. It's going to give you some decimal number, and that'll round down to 0, which means you're in the first row on the Y, the columns. So you're on the very top of the map. Okay. Then it runs through a few things here. Once it knows what tile you're in, it's going to check that against a couple things. So it's going to check if your grid X or your grid is less than 0, sorry, so you're off the map or where you shouldn't be. It's going to check your grid X to make sure you're not on the furthest part. So I look at self.grid, which I think is, where do we define that? Grid. Where does that get passed in? Okay, so your grid comes from this whole thing right here, but we'll get to that soon. So it's going to make sure that you're not off the maximum size of your grid. So in this case, I think it was 40, if I remember correctly, just based on how this works here, this loop. Looks like it's 40 tiles to the right and 40 tiles down. So if you're at tile 41 for some reason, even though I think we have another part in our code that prevents that from happening, it's going to return true, meaning you're at a wall. So you're at the edge of the map in this case. And it does the same thing for the Y. And then this part here, so assuming you're in the correct place, assuming you're inside the map, it's going to do this part. It's going to check your self.grid. So your grid is what we passed into this maps function here. And all it is that box of values. I'm not really counting, but so if I go here and then I go here and I make a grid, all that is telling us right there. So this grid is a bunch of values. And apparently the tiled program doesn't use ones, it uses 502s for some reason, but it means the same thing. It's either you can go there or you can't. You only have two options. So that's what that grid refers to, is it's going to check your location on the grid, your y value and your x value, to make sure that you can walk there. So if it's a 0, if you're at this place in the grid, you're going to be able to walk there. If you are on this tile in the grid, you can't walk there, and it's going to return true, meaning you've hit a wall or your position is a wall, and it will do something else there. So all this array here, this is how I got this. If I didn't get it from the person who made the video on scripters lore, is you would have put all these numbers into that tiled program, and you would have given each tile its own property of can I walk there or not, and it spits out this when you like export the image or save the file. It will let you download this chunk of code, which is just a really long line of zeros and 502s. Now, for the game, we don't really want this to be in one long line. We want it to be in rows and columns like I just had it a moment ago. And that's what this for loop does, is it has this array 2D. So an array is any value, like I can make a really short one here. You just have rows and columns. So an array is two-dimensional here, 2D, because it's got a height and a width. So that's how it's going to be best for us to implement our game collisions, is if it's in a collision like that, or in a format like a 2D array, instead of this long string of values. So what this loop does is it goes through, and I personally think it would be better if we had some way of knowing that it was 40, like a length or a width of your array, or a length or a width of your image. But he just had us hard code them in for right now. So it says for each increment or value I, when I is less than 40, you're going to loop through and do all this code. And after you do the code once, after you do all this, you're going to add 1 to your loop value, and you'll check it again. If I is less than 40, you're going to do this code again, and then you'll add a value to I. And then since it's a value of 2 on the third time around, since we started at 0, you're going to keep doing this until your I is 40 or bigger. It's going to be 40 though when it kicks off. Okay, and then what you're going to do there is your array 2D, the first row, the I is going to be empty, but then you're going to add stuff to it. So for the next one, you're going to go, well, for the first 40 values, so I think they're all zeros, but let's just say that this is 40. I don't really know if it is or not, but let's say that that was 40 zeros. It's going to go through each one of those and going to set the first value here as 0, and the next one is 0, and it's going to do that 40 more times, and then it'll go to the second row. And it'll go to the second row. As you've gone through 40 values here, you've looped through them, and then you go back to your original loop, and you go to a second value here. So you're going to add that to there, the 1. This means add 1 to I. So then that means you're going to be, I know that's an issue. Okay. Anyway, then you will be on the second row, and I'm pretty sure it starts at 0 again, but maybe eventually you run into a 502 where you can't walk. and it just continues. And you'll end up with a 40 by 40 two-dimensional array with this code here. So you'll have 40 values this way and 40 rows going down. And then it matches up to how we're going to implement this game. Okay. Because when we have it in a 2D array, it kind of matches our idea of how this map is pictured. It's a flat 2D image. So if you have it in one long line, it doesn't really make sense. But if you have it in rows and columns, then we can do things fairly easily. Okay. Like check your grid Y and your grid X. So that's what this means. When I go self.grid, what I'm really doing is testing this little 40 by 40 array, and I'm going to find which value is at a certain location. So I have to have a Y location and an X location. I always do my Y first because the first one in an array, this thing right here, the array, tells you which row are you going to look in. And then the second value tells you what column are you going to look in. So you always do Y, then X. Okay, so let's go find where we actually use this at. Should be in, let's find it here. Okay, not actually done there. I pulled up a different kind of find than I'm used to. Is position. Okay. We've got it right here in the self.update function, which is part of the actor. Okay. So what we do for the actor, which is the enemies and the player, we're going to figure out, we're going to store where the old X is and where the old Y is, because we want to be able to go back to those values after we figure out if we've hit a wall or not. And then they use this kind of concept here of bumpers. So there's several different ways that you can represent your player on a map, figure out if the edge of the player hits something or not. One is testing each pixel on the outside of the picture, even though it's all sorts, like the player is all sorts of crazy shapes. It's nothing super geometric, like you can't describe it as a rectangle or things like that. That is possible to do, but it is apparently, and I would imagine, very intensive to test every single pixel on the edge of the image to see if it bumps into something. You'd have to code in a lot of different things to get that to happen. Another way is to test rectangles, but rectangles, according to the video, don't work well for this grid that we did, like having ones and zeros, 502s, I guess they are. But then this bumper concept is creating different points around your player or your enemy that you're going to test them against. So we made it a left bumper, one on the left side of the enemy and the player, one on the right, one on the top, and one on the down or bottom of the image. So then what we're doing in here is just setting those values. So to get the left bumper, I subtract 40 from my X position, and I just use my Y, which is pretty much centered on the character. And then I add 40 for the right, or I subtract 16 for the Y, or add 64. These numbers you just kind of get from changing until you get kind of the right distance, or you can count from pixels to figure out where you want them to go. But otherwise, just creating these bumpers. And then what we do is we use that function for the current map is positional wall, and we test each one of the bumpers. So if the position is a wall, what I do is I actually set my self x to subtract 5 from it. It self corrects itself. Okay. If it's not a wall, then I will move like I'm supposed to move. I'm going to add my max speed to my X position or my Y or anything like that. So nothing, this is kind of the normal function, like how we moved before. The weird thing here is I can show you the kind of the implementation of this. If you do hit a wall, it's actually going to move you away from that wall slightly. So let's take a look at what that looks like. So I don't think we've seen this yet with code working. Did I save it? Refresh. Okay. So now I can't go through rocks. I can't go through the pond. I can't go through stumps. I can't go through the building. There's obviously some issues. One of them is just the way this game has been made. The tiles don't match up perfectly, so you end up having some space that looks like you could have walked on it, actually not be able to. So now if I wander over to a object, and all I'm going to do here is push the right button. So notice that eventually I moved up a little bit there. So that's what that, if it is a wall, it tries to move you away from the wall. But that also caused an issue, because if I move into a wall continuously, it creates this shaking. So it's not a very smooth image. And I just sit here and I shake back and forth because what my button press is doing is saying move forward. The code says, hey, this is a wall. I'm going to move you down 5. But then you keep pressing, so you just keep going, I want to move up. The game says, nope, move down. Then you say move up. The game says move down, and it just creates this bumpiness. So that's what supposedly we're going to fix in the next episode. The other thing that happens here, bullets go away when they collide with different edges now too. So that functionality has transferred over. And what was the other thing that we did in this episode? Oops, why did that move over there? Okay. Okay. Where's the bullet? Actually, let's take a look at that. Bullet. Okay, so here's the other place that we used is position wall. So we tested the bullet. If it's hitting a wall, whether that's the edge of the map or a wall of a building, a rock, anything like that, we change the value of to remove to true. So then that's going to get rid of the bullet right down here. So if self.toRemove is true, it's going to delete the bullet. So that's why the bullets now disappear when they hit objects as well. Otherwise, I am having a moment here, and I can't remember what else we did in this. Okay. I think that was the main gist of it. So otherwise, we're going to, from what I understand at the end of this video here, get rid of that bumpiness when we go up against a wall of some sort by implementing speed and acceleration instead of just changing the X and Y directly. So if I'm hitting a wall, I shouldn't have any speed in the Y direction going upwards. So if I change that value to 0, then my X isn't going to change by that speed every time, and it's just kind of starting to implement a little bit more physicsy stuff, I would say. Some physics engine capabilities, some pretty basic stuff. Otherwise, I will see you the next time, and I think we've got 3 episodes left. I might just do all 3 of them on the next video, and then I can start making my own games, I guess. All right. Thanks for coming.